Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 1.1 for Intro to Statistics, an introduction to data, as well as the information presented prior to section 1.1 itself. There are a few definitions introduced in this section that we need to consider, the first of which being data. We will call any observations gathered from field notes, surveys, and experiments data. There is a common misconception that data needs to be numerical in nature, such as the height or weight of an individual. However, this is not necessarily the case, as data can also take non-numeric form, such as an individual's hair color. Also note that data can come from multiple different sources, so there are many ways to gather data. The science of using and applying this data is known as statistics, defined specifically as the study of how best to collect, analyze, and draw conclusions from data, otherwise known as making inferences. Note that analyzing, which is typically where calculations will lie, is only a part of statistics, and a majority of it actually has to do with the methodology of how to gather and how to infer. There is a step-by-step process of 6 stages that you will see conducted in most of, if not all, examples in this class. First, we will identify a question or problem that we wish to answer, followed by designing a study and collecting relevant data on the topic. Pay careful attention to the fact that the question is asked before the data is gathered. It is generally frowned upon to gather data and then design your statistical analysis based on what you've gathered. If you do it in this way, it is very easy to become biased in your analysis. Next, we will describe the data, which typically means we will summarize it with tables, graphs, or statistical calculations, such as the mean, which you will learn more about later. This step, combined with step 2, are part of the collecting phase of statistics. In step 4, we are going to make a statistical analysis, which can take various forms, depending on the question and the data considered. This is the analyze phase, where a majority of the calculations in the class will come into play. Once we've made this analysis, we then make inferences about the results in context, which means we are going to describe our results and show how those results can be applied to a larger, more general situation. However, statistics is not an exact science, and mistakes can be made along the way, whether those are major errors or just problems with optimization of the process used. That is where step 6, contemplate and consider, comes into play. We will reflect on what was done and offer suggestions for improvement of our own process. We will look at a quick example of this, but before that, we have one more definition. That definition is the definition of a statistic. A statistic is a single number summarizing a sample of data. There are many forms of a statistic we can have, one of which will be a simple proportion, which you will see in the coming example. 2 important things to note about this. First is the fact that calculating statistics will be part of step 3 in our above process, and the fact that it is a value describing a sample is another note that you need to keep in mind. That will be very important for us moving forward. As for the example, let's look at the situation that is given to us, which is already broken up into the 6 step-by-step process. This is a class activity for eye color. In step 1, it says, according to a Harris poll, 45% of Americans have brown eyes. Does the proportion of people with brown eyes in your class support this claim? This is going to be our question, the question that we want to answer. Note that we are looking at this question, we're looking at the situation before we've gathered any data. That will come into step 2. For the sake of simplicity, I'm going to come up with some simple numbers for this. Let us say that we have a class of 25 students. Which I will split up into how many have brown eyes and how many have non-brown eyes. Let us say in this class of 25 students, let's say 12 of them have brown eyes, and the other 13 have non-brown eyes. This would be our collection stage, where we just gather the data, and then in step 3, we want to present that data in some way. Technically, the table above is one way of summarizing that data. However, we can also summarize with a statistic. Question 3 here says, what percent of our class has brown eyes? That percent that we have is going to be our statistic that helps describe the sample that we have of 25 students. To find what percent of students have brown eyes, we are simply going to take the number of students that have brown eyes, which is 12, and we are going to divide that by the number of total students in the class. 12 out of 25. If you divide those two, you get 0.48, which, when converted to a percentage, is 48%. Meaning that our class, our sample here, has 48% of students with brown eyes. Note that that is different than what was provided. It said that 45% of Americans have brown eyes. So for step 4, is the value for our class 45%? No. It likely will not be exactly 45%, although it is very well possible for that to be the case. However, when analyzing this, we also ask, does it seem close enough to 45% that the difference is just due to chance? There are going to be some more specific statistical calculations that we will dive into later on in the course, but for now we can just eyeball it and say 45% is pretty close to 45%. It's not too far off. It's likely just a little bit of difference based on random chance. So I would say yes to this question. It's close enough. If maybe my value was 58% or maybe 22%, I would start to question the original value provided, that 45% have brown eyes, because our sample would be so different than that. Based on my information, does our class support the claim that 45% of Americans have brown eyes? I would say yes. Our class does support the claim. So yes, in context, the value that we have of 48% is pretty close to 45%. So it does seem that we are supporting the original statement provided. However, remember what I said earlier when talking about step 6? Statistics is not an exact science, and mistakes can come along as we go, or maybe there is an issue with the way that we went through this. Question 6 here says, is there anything about our study that should make us think twice about our conclusion? What could we do to answer this question better? There are many different answers to this problem, because when analyzing a situation or critiquing it, there are many ways to adjust and change it. However, a couple things that I would point out would be the fact that what we're analyzing is a class of data. So we're looking at individuals that all come from a specific region. That could be a problem. Also, the fact that I have only 25 students in my sample. So I would say first, it's a pretty simple sample to use. It may not accurately describe the population well. And I'd also say that it's a pretty small sample. For example, what if instead of having 12 students with brown eyes and 13 with non-brown eyes, I instead had 120 with brown eyes and 130 with non-brown eyes? Now I am studying 250 students. I have a much larger sample and that inherently sounds better. I have more information that I'm working with. This would still give me the same percentage as I calculated. However, the fact that it's coming from a larger sample usually lends a little bit more security to the situation. That about covers it for section 1.1. If you have any further questions, be sure to review the example videos or ask your instructor.